Francisco, and thank you everyone for coming today. It's about 7 o'clock at night here in Minnesota in the U.S. And to help acquaint yourself with some of the new capabilities in Oracle 12.2. And the things we'll be talking about today are all essentially brand new to the container database architecture of Oracle 12. And 12.2 I'll be talking about very briefly later. At about the same time as Open World in a couple of months, Oracle will be announcing Oracle Database version 18. And all of these things will be carrying forward into version 18. Don't get shocked. I'll explain that when we get to the next slide. I use an unsafe harbor statement because I don't like the fact that presenters for Oracle Corporation are always using a safe harbor statement to say that they are not responsible for what they say or that what they say may or may happen. I only talk about things that are released product and things that I've personally worked with. So I have an unsafe harbor statement saying essentially I've done everything, and every line of code that you see, everything that I show here really does work. Next slide. And go past that red introduction slide to my introduction slide. My name is Dan Morgan. I was an Oracle ACE about 8 to 10 years. I was one of the very first ACE directors. I'm now a program. My background, because of my age, consists of having done a lot of things and no longer doing them. I spent 10 years as the author of the University of Washington's Oracle program and taught there as the primary instructor 10, 11 years. I did some lecturing at Harvard University and have lectured at universities on 4 continents so far. Background-wise, I started off in mainframe computers in 1969, writing Fortran. Later on, went into the client-server age when mainframe databases were being moved into client-server on VAXes and the original Sun architecture. Been a beta tester for Oracle since 1988 on the database and also for Golden Gate, doing Golden Gate beta testing right now and a number of other products. I'm the Morgan behind the Morgan's Library website and a member of the Oracle Data Integration Partner Council. My current job, they gave me a title of Principal Advisor, which I assume means they gave me permission to tell them what to do. Every once in a while, they actually listen to my advice. Here's a screenshot on the next slide of the homepage of my website. If you've been led there by Google, I've written just about every line of code on that website, and the few that I haven't written, you'll find the names of the authors, but the vast majority of what's there is mine, and always appreciate emails when people find broken links or have code examples that aren't there that they'd like to have hosted. Next slide. My background right now includes a lot of activities around the Oracle database, a lot of work with stability. We find that a lot of databases are on the wrong hardware and configured incorrectly, so a lot of stability work. Next slide. I do a practice in Oracle database and security around the Oracle technology stack. In the U.S. is the second largest security integrator in North America, U.S., Canada, and Mexico. And therefore, I spend a lot of my time also. So a lot of work with database performance. Next slide. A lot of work with zero downtime, migrating very large databases where we can migrate databases without any downtime. And most recently, the next slide, what we call just-in-time IT procurement. A lot of people like to call it the cloud. I've got cloud as just sort of a joke word. It's just some marketing jargon. But what I do like is the ability to, rather than going out and buying servers and spending weeks setting them up, being able to procure resources, whether it's storage or networks or servers and databases, with an hour lead time. So what we generally find now is by using the Oracle Cloud, we can deploy just about anything we want if we have 1 hour's notice, any amount of CPU, any amount of storage. So I look at it much more as a procurement issue than as there's something cool called cloud, because as I said, I'm not that impressed by the cloud as a concept, but I do like the procurement aspect of it. From my next slide, I've got a cat and an eagle. Slides like this just to emphasize the point that when we get into new versions of the Oracle database or new capabilities or new architectures for deploying things, that we need to acknowledge that we are, in fact, going into a place that we've not been before. There are going to be some surprises there, and we need to be careful about taking notes, documenting what we're doing, so we can turn it into a repeatable process. And certainly getting into the Oracle containers and PDBs with 12.2, it's not just different from every version of Oracle there's ever been before. It's even substantially different from 12.1, because everything that I will be showing you today, you cannot do in 12.1. It's all going to be brand new to 12.2. So, next slide. I'm going to introduce you very quickly to the Oracle Database 12c, just so that everybody sort of is coming at this from the same point of view and sort of understands how I'm approaching this. So let's go to this next slide. It's titled Oracle Database. And I like to start off with this for two reasons. First of all, it gives a really good perspective, I think, on how far Oracle has traveled. And also for many of us who've been working with the Oracle database for 15, 20 years, why this all seems very unsettling. There never was an Oracle database version 1. Oracle was founded with the name Software Development Lab by Larry Ellison and a couple of his buddies from IBM. And Larry was smart enough back then to know that nobody bought version 1 software. So the very first version of the database that was released was version 2 in 1979. And to say it was primitive would probably be to overstate the case. It was very, very primitive. But the first really significant piece of the Oracle database that we recognize today showed up, beyond obviously tables, showed up in version 4, and that was the introduction of redo logs. The ability to log the transactions and to do essentially a recovery of a point in time. There was no such thing as undo or redo back then. So 1984 was really that first time that we got a hint of where the database would be today. Next slide. It was another 5 years, Oracle 6, when we see the next piece that we can relate to in terms of our current version. Oracle introduced rollback segments. That was the very first time that you could really do a rollback instead of versus a commit. You could do it previously, but it was a completely different mechanism and not particularly efficient. And it was in version 6 that Oracle introduced triggers and a little bit of the PL SQL language. At that point, if you really wanted application code, you were using the compilers like Pro-C, Pro-Cobol, Pro-Fortran, and you were compiling your code exterior to the database. In the next slide, I go to Oracle 7. That's 1993, 4 years later. Oracle introduced the full PL SQL language with stored procedures and packages and functions. What's interesting from 1993 to 2013, which is the next slide, is that there were no changes at all. Oracle introduced RAC, but it really didn't change anything in terms of how a DBA interacted with the database. They introduced data guard, they introduced streams, they introduced a lot of capabilities, but none of it really changed that fundamental architecture of what it was that we were looking at. If you were a DBA in 1993 and you learned Oracle 7.0.12 or 7.3.4 when it finally came out in that terminal release. You could, up until 2013 version 12, have been pretty much using the exact same scripts, looking at DBA tables, DBA objects, $$ parameter, and nothing in your life would significantly have changed. So you could get into this point of view, which I personally did, of I know Oracle, I don't have to read the docs, and I can just go fire stuff up and it's going to work. With Oracle 12C, 12.101, and I was involved in the beta there, Oracle introduced a brand new architecture, and my very first experience with the 12.1 beta was that I tried to create a table space and I failed. And I tried to create a user. I tried to do create user, and I failed. And I thought, wow, this is the worst beta Oracle's ever had. And I logged an SR, and Oracle said, try reading the documentation, idiot. And this idiot finally read the documentation and realized that the old create user wasn't going to work and the old create table space wasn't going to work. They'd really made significant changes to the architecture, and I was going to have to go back and read the docs in order to work with the new container architecture. So if we change slides, finally 2016, 2017, Oracle makes another major change in the in 12CR2 with application containers, and that's what I want to focus on today, because the container architecture of 12.1 still exists, but it was really just a first step to get to where 12.2 is. 12.2 is really, if not the entire architecture, the vast majority of this particular architecture. So let's go to the next slide, and I want to talk about the new physical and logical architecture and give you a sense of how dramatic the change is and how it relates to what we think of as a database in Oracle. And in this next slide, I've got three diagrams. On the upper left, I've got version 2 to 11. And this is really a pretty good representation of the Oracle database. We had the instance, which was processes like PMON and SMON and LogWriter running in memory. We had data files mapped logically into table spaces. That was the database. And in that database, you had storage in the form of data files and table spaces. You had objects in the forms of segments. You had users, but everybody was pretty much all in the same bucket. And the only separations were the logical ones that said, I'm going to create a schema. The schema owns some tables, and a DBA can log on /assist DBA, and they can do select star from, and they can see anything they want to see. And that breaks in 12.1 when you get into this initial container architecture. And Oracle introduced the concept of having an architecture with a minimum of 3 components when you had the containers. And the first component was what is called CDB root. And it is, in effect, the Oracle Data Dictionary. It's the root data dictionary. It contains things that are owned by system, the things that are owned by sysocs, XDB, MDSys, WMSys, those kinds of things, but are basically that generic underlying piece of the Oracle database that has nothing to do with you as a DBA or as a developer and your application, your tables, your data. They had a pluggable container called the seed, which could be cloned to create pluggable databases. And then there were pluggable databases. And the concept that we got with 12.1 was that these things would plug into root, and they would have access to the root's data dictionary by pointer. So if you created if a table was created in root, then you could possibly see it by pointer in the PDB. But if you created the table in the pluggable database, it was invisible to root. So it was pointers going one direction that brought the data dictionary down. With 12.2, Oracle added another logical layer. So if you look on the left, you'll see that they still have something called seed as PDB $seed. But rather than having pluggable databases plug into root, which you still can do, the concept became that you'd plug in an application root, which would essentially be your application, your tables, your views, your PL SQL code. You could create an application seed that was essentially a copy of your application that you could then clone. And then each of the pluggable databases, they show them here as customer 1 PDB, customer 2 PDB, would be an inherited copy of your application. So if I were to patch the application root, I would patch every single one of my customers. It makes it a whole bunch better. It also allows me to put one customer into one pluggable database, one customer into another pluggable database, and I can patch them, I can manage them from a data dictionary standpoint, but I cannot necessarily see their data. Again, there's that isolation. The customer 1 can't see customer 2's data and can't even look at common data dictionary objects. They both look at $sign users or $sign database or $sign instance. They're looking at completely different information because it's specific to their container or their pluggable database. So improved security, improved a whole lot of different aspects of the way the database worked. Let's go to the next slide. If any of you have a background in Informix or Sybase or SQL Server, this diagram will probably look pretty familiar to you. And what will make this familiar to you is the fact that the diagram on the upper left comes off of a Microsoft website. And the diagram bottom right comes from the Oracle website. And what this illustrates is that what Oracle did when they adopted the container architecture, and something else that they did very extensively in 12.1 and continue to do, is to integrate all of the capabilities and architectures from other databases into the Oracle database, so that in essence there's nothing you can do in SQL Server that you can't do in Oracle. They built in SQL translation where you can do real-time translation of transact SQL into PL SQL. They built in identity columns so that they could, in a Oracle database, have both identity columns like SQL Server and also use sequences, which is the traditional way of numbering pseudo-columns and surrogate keys in an Oracle database. So the master database in SQL Server corresponds essentially to PDB root. The model database corresponds roughly to what we will refer to as a seed, whether it's an application seed or PDB seed. And the user databases within a SQL Server database map to the individual pluggable databases. Now, this is not a one-to-one mapping. There are some definite differences. You'll notice, for example, in SQL Server, they have something called temp DB. We would just say temp table space. And when you get into 12.2, you've got multiple temp table spaces, but we wouldn't view it as a separate database. So this isn't a real one-to-one mapping, but there's just a lot of similarities between them. Let's go to the next slide. So if I look at the 12.1 container architecture, it looks a bit like this, where I've got a database as sort of this concept of I've got a bunch of related physical files and instances talking to them. I've got my root container with my data dictionary, systems, sysocs, those things. I plug in my seed. I plug in a pluggable database for development. That's the 12.1 architecture. Let's go to the next slide. I now have something called application root. And this is the code I'm going to show you and explain to you how it works. We'll step through this, and you'll all have the source code so that you can replicate this. And it's all on my website as well, so you can always cut and paste off of the Morgan's Library website. And the concept here is to build an application root container. And the application root, again, I build my tables and my views and my PL SQL objects, anything else I want in there, so that when I plug things into it, if I wish to, they can inherit all of those things without me having to go in and recreate everything over and over again. Now, into that application root, I might plug 3 or 4 development pluggable databases for my developers to work. I might plug in a QA database. I might plug in a user acceptance testing database. In each case, I don't have to do any work to set them up other than just to say, and 1 or 2 minutes later, I've got a working Oracle people can start using. So let's go to the next slide. And in the next slide, you'll see I've created an application seed. Next slide. I've plugged in some of my customers. So I've got customer 1, I've got customer 2, customer 3. They're all sharing the same tables in terms of the DDL. They're sharing the same views, the same operators, the same procedures, the same XML, the same whatever that's coming from the application root. If I wanted to put a table of cities and countries and airports up in the application root, they could all see that. But if I built a separate table inside of their PDB, it would be private to that pluggable database, and no one else could see it. No one could query it. It would be completely private to them. So you've got the ability to have public data for the application, private data for the application. Let's go to the next slide. One of the nice things about the way Oracle did this, and this is a departure from that Informix Sybase SQL Server mode, because Oracle said, well, yeah, we like what they did, but we're going to extend it and make it work better, was that there is no concept of application roots and application seeds in those other database products. When Oracle decided to embrace and extend, the concept of the application root was that I could have an application root for version 1. While people are using that, I could go and I could build another application root for version 2. And they could both be running at the exact same time on the exact same hardware using with complete total isolation. And if I wanted to test one of my production users in version 1 with version 2, I could ask them, hey, is it okay if I push you over to version 2 for an hour? And if they said yes, I could take and unplug their PDB from the green version 1, plug it into version 2. That would probably take somewhere in the neighborhood of 30 to 60 seconds. They could be working in version 2. They could say, hey, we really like this. We want to stay here. Or they could say, oh, man, we found a whole bunch of bugs. We don't like this. 60 seconds later, they're plugged back into version 1. And we could use a tool like Golden Gate or an export, whatever we wanted to do, to essentially take any transactions they did in version 2 and run them back to version 1. So lots of capabilities here. At the same time, fully enforced security, too, if we wish to have it. Let's go to the next slide. So on that second one, you'll notice the first one now is designed for production. Customer 1, customer 2, customer 3. My second application root is a development environment, a QA environment, a user acceptance testing environment. And again, all working with that same ability to inherit a lot of the code. Let's go to the next slide, talking about container database user architecture. When 12.1 came out, my error when I discovered I didn't know how to create users in an Oracle database anymore was that I hadn't bothered to read the docs and had no idea what a common user was. And the concept of a common user in Oracle is a user that when you create them appears in every single container. So if I go into CDB root, the very top of the hierarchy, and I create a user there, that user will appear instantaneously by pointer in the seed database, in the application root, in the pluggables under the application root. They're everywhere. If I create them in the application root, they don't appear except in the pluggables under that particular application root. A common user, and this is why I wasn't able to create a user when I first logged on. I logged on doing /SSDBA, create user ABC, identified by ABC. Oracle said, what on earth are you doing? Go read the docs. And what I discovered is a common user has to be prefixed with C, number sign, or C ##, depending on how you identify that particular character. In other words, there's a prefix so that Oracle knows to now push it by pointer into all of the containers underneath that particular root. So local users, if you just went in and created user ABC, you could do at the PDB level, but you couldn't do it above at a root level because that's restricted to you must have the C ## prefix. And you notice that on the right side of the slide where it talks about Oracle supplied users and user created users. Now, that was in 12.1. Let's go to the next slide and look at what Oracle did in 12.2. They added an application common user. Application roots didn't exist in 12.1, so they weren't able to implement that at that point. They added the application root directories or containers in 2, and therefore we got another version of users they call an application common user. So another way of emphasizing the critical reason to read the docs before you go there. Let's go to the next slide. Now, there's 2 reasons I have the slide here. One is the obvious, which is Oracle created some new users, and you need to be aware of what they are and who they are. And the second one is, I hate to break this to the DBAs, but Oracle is probably going to announce that they're deprecating sysdba. They want to make sysdba go away. So what we saw in 12.1 was the introduction of a user by the name of sysbackup, another one sysdg for data guard, and syskm for key management, which is essentially managing the keys for transparent data encryption. In 12.2, ggsys for Golden Gate, a user called pdbadmin for administering pluggable databases, and a user by the name of sysrack. Oracle is viewing sysdba as a massive security violation. Too much power, and if somebody wants to run RMAN, we've got to give them access to the whole to everything in the database. And somebody wants to manage a rack cluster, we got to give them privileges to everything. And somebody wants to set up data guard, we got to give them privileges to everything. So what Oracle is doing in preparation for deprecating sysdba is they're setting up individual users for performing DBA functions that used to require sysdba. So it used to have to be sysdba to run RMAN. Now you can use sysbackup. You take that privilege away, or the excess privileges away, and you only have the privileges you need to do backup and recovery. Same thing with data guard, key management. So I've got a slide here, next slide, that says new users with escalated privileges that gives some sense of what these particular users are and how Oracle expects us to use them. You'll notice that the ones that came in 12.1, sysbackup, sysdg, and syskm, are things that we can use. We can assign these to humans who can do work. ggsys and sysrack, Oracle says, do not unlock these. These are not for you. What we're going to do is we're going to give these to our management tools. We're going to give these to Golden Gate. We're going to give these to an agent for rack server control and to clusterware so that they can do these things without having to use, again, those massively escalated privileges. So again, be well aware of the fact that this is coming. So let's go to slide 32. If you don't think this is the following. Now, this is unannounced. This is the only thing I'm going to tell you is sort of speculation that's been publicly announced. I'm not DA by telling you this. People just or in talking. So I'm not giving you anything that should hold, oh my goodness, this is confidential. Decided to start releases every single, so instead of waiting to go from 1 to 11.2 or 12.1 to 12.2, Oracle wants to do a major release annually. And they decided to number them based on the year. So it wasn't that they were afraid of having version 13, 14, 15, 16, 17. It's just that when they release it, it will be Oracle fiscal year 2018. It will be essentially open world, and they're looking forward to sort of the official release being between October and January of the year 2018. So Oracle 18.0 should be released about the same time as open world on the web only. It will then be released for the public as 18.1 in January, and you're probably used to quarterly releases, so expect 18.2 in April, 18.3 in July, 18.4 in October, and that's what you should see. Then come open world next year, you should see Oracle 19.0, then in January 19.1 and such. So That's what we're being told we should be looking forward to. We're also hearing that Oracle may convert the database into RPMs for delivery and migration and patching and upgrades via a Yum server. We're hearing that the database kernel is being rewritten so that almost all patches will not require an outage going forward. We're expecting OEM and other tools to now start working through the REST API, and there are even that OEM is going to go away completely, just not a good architecture for companies and products, handing them. Surprisingly, there's discussion of going away. So when we start talking about changes that have happened between 2013 and compare that to the 20 years between in 2013 happened, expect to see very, very significant changes happening, and that's part of what I'm going to be showing you as we get into this multi-tenant architecture right now. So let's go to this next slide, and we're going to talk about multi-tenant architecture, and we'll move past that red slide to the multi-tenant business case. There's why Oracle is going multi-tenant. And to go multi-tenant with a single tenant does not require any additional licensing. It's free. It's included. You can go to that and you don't owe Oracle a dime. It's only if you add multiple pluggable databases that are user-defined pluggable databases that you owe them money for the multi-tenant license. But essentially, Oracle is expecting that that's the way everyone will want to go at some point. So let's talk about why they're going that way, and then I'll show you how to build it. They're really thinking in terms of a concept that we're hearing a lot about called software-defined everything. We started off with software-defined storage. To a great extent, a ZFS storage array from Oracle is software-defined storage. You go into a GUI, you say, here's how many disks I want, and I want this many storage pools, and I want this much whatever, and this much redundancy, and you click build, and it builds it for you in a matter of a few minutes. It's really software-defined storage. You don't necessarily go on there like we used to and create LUNs and directories and all of that. As much as you're just letting code do all of that work for you. Then we had storage networked by software. So Oracle bought a company a few years back that does software-defined networking, and we're seeing with a lot of the converged systems like Nutanix, Cisco UCS, VCE vBlock, a lot of systems where they're building essentially software-defined combinations of compute servers and storage and networking all within a single frame. That's where the industry seems to want to go, and a lot of that plays directly into the cloud. A lot of that just plays into lowering costs and simplicity. But from a DBA standpoint, from an Oracle database standpoint, what you're looking at is far more rapid provisioning. If I go into a let's just say an Oracle 18 database, my ability to, that's when you're talking to a beta tester, you get these things sometimes. If I go into an Oracle, we'll call it 12.202 because it hasn't been released as 18 yet. If I go into that and I decide to go create database, once I have my initial root container, I can probably do a create database on a laptop in 60 seconds. You can't do that the way you work in any other database. If I decide to create 20 databases, I can do it in parallel. I can probably build 20 databases in 10 to 15 minutes on a laptop. So there's a huge, huge difference in provisioning speed. There's a huge difference in terms of, I can unplug something, I can plug it in somewhere else. I can plug it in on the same server, I can plug it in on a different server. Unplugging and plugging something back in, we're literally talking 60 seconds on a laptop. So much, much faster on a real server. In terms of logical customer isolation, I can now build databases where DBAs can't look at the data, and where one person in a table can't look at the data owned by another person in the table without having to buy any kind of advanced security licensing. A lot more granular control going on, a lot more ability to scale and utilize resources. We often are running our databases at 20 or 30% of CPU capability because we're worried about the peaks. We're worried about somebody starts doing something, requires a massive amount of CPU. When you get into this container architecture, you have a lot more control over your ability to manage I/O resources to storage, CPU resources, and memory resources on the basis of an individual schema as opposed to on the basis of a database. And you can easily hit substantially higher utilizations and, of course, improve security. Let's go to the next slide and talk about creating an application container. I've given you enough setup. Now let's talk about actually building one. And at this point, the PowerPoints are here only to provide source code. So my first slide is demo 1, and it says create an application root, and I'll what it's doing. I'm logging on as sysdba, and one of the first things you always do in a container database is you make sure you know where you are, because what you discover is that sysdba or sys or sys system or xdb or whatever, those root schemas, the ones that are running the database, are in every container. So if you have 6 containers, you have 6 identical logins in terms of user ID and password to log in as system. But depending on which container you choose, you could end up in UAT, you could end up in production, you could end up in development, you could end up in one customer or another customer. So you always have to be really careful to do what I call checking your geography and make sure. So I say show con ID. It shows me that the container ID is 1, which means I'm in the root container. And I say show the container name or con name. And it shows me that the con name is CDB root. I know now precisely which container I'm in. I do a select from a dynamic performance view, $containers, ordered by the container ID, and I see that I have built a database with a root container, CDB $root. It has the default seed that Oracle builds when you build one, PDB $seed, and then there is a pluggable database I created called PDB-dev, and I just did that as part of running DBCA and creating my database. Let's go to the next slide, and I'm going to do over these next 5 or 6 slides is walk through the syntax on the left and what I'm doing on the right, so you can see how these things balance out. So the full syntax is on the left, and my typing it in at the command line in SQL Plus is on the right. So if you look at the Oracle Docs, create pluggable database, and it's like, well, what's the name of the pluggable database you want to create? I'm calling mine UW App Root. UW because I taught at the University of Washington, and all my demos are still based on that naming convention. It keeps it consistent. But the important part here is App Root. It's my application root. Next slide. And here what you see is that Oracle's saying to me, okay, you want to create you want to create a container. What is it going to be? Is it an application container or is it a seed container? Now, in this case, I'm creating an application root. So I'm going to say as application container. And now I've got a pluggable database called UW App Root. It's going to be an application root. And the next line is admin user and identified by. Now, here's where we start to get this extra security, because the admin user is not sys or system. I'm creating an administrative user for my pluggable database that essentially is the owner and the manager of my pluggable database. So my admin user is UW admin, and because I don't believe in good security when I'm doing demos, word identified by is also UW admin. Let's go to the next slide. The next piece is roles. What roles am I giving to my administrator? Now, I can create a role that is specific to my application. Now, Often in an application, if you think in terms of e-business suite or Siebel or PeopleSoft or SAP, the application administrators are not the Oracle DBAs. They're not the SQL Server DBAs. They're people who are managing the application. What we're looking for here is somebody who's managing an application root. It's probably, in this case, going to be either an Oracle DBA or an application DBA who's going to be focused not on building table spaces, not so much on the normal performance tuning, I need to go look at X dollar sign, whatever stuff, but somebody who's going to be more focused on the performance tuning and the security and creating users and patching and maintenance of an application. So I'm going to go out and create a role, one or more roles, and I can assign them to my administrative user. Let's go to the next slide, which is slide 6 of 12. I can now build or define a default table space. Now, in this particular case, I'm calling default table space UWApps TBS, just to stay with my naming convention. Next slide. Then there's a file name convert. Here's where that seed database concept becomes critical. We're going to define every single aspect of the database. How much memory, how much temp, how much this, how much that. What I'm saying is, file name convert. I have a seed database. I want you to go and use my seed database and essentially clone it over into a different physical directory. So my seed database was in a directory called PDB seed. And what I'm saying is, under the root, I want you to create another directory in my file system called UWApp, clone it over there, and attach it as an application root called UWApp root. So I cut the creation of this new database down to take something, copy over a physical file. It's not like your normal create database where you have to take a bunch of source code and you compile DBMS standard and you compile util file and you compile DBMS stats and you create all these tables and views. And you've got all this compile time. It's literally take a seed, copy the seed, and everything is there in usable form. Let's go to slide 8 of 12. User table spaces. As part of creating this container, I'm not going to create any user table spaces. That's going to be part of whatever script I run to create my application. And the next slide, 9 of 12, I can choose whether to do file system like logging, where it logs to the file system. I can do no logging, which is sort of a joke if you have a serious application out data integrity, or logging, which is always my default. And the next slide, I'm going to go and create it. So I've got the full syntax. I've got my full create application root on the right in SQL Plus, and it says pluggable database created. So that would be the step that you would use to create an application root. Let's go to the next slide. Application root there. Keeping in mind, I'm still logged in as sysdba in my root container. I can't go into and query that thing because I'm not logged into it, but I can look at the metadata in the data dictionary about it. So I can query $$ containers again, and whereas last time I only saw my first 3, I can now see that my UWApp root container exists. It's in mounted state. It has not been opened. And the very first one of those things where it says yes, no, no, if you look up at the SQL statement, it says application _ PDB, and it's saying, yes, you built an application PDB. And then I do an alter pluggable database, and I open it up, which makes it read write. Now I can go into $$ services, and I can see that Oracle not only created the pluggable database, I've opened it. There's now a service that I can connect to. So I can go into tnsnames.org, and I can create an entry in TNS names or JDBC or ODBC driver, and I can now connect to that application root. Let's go to the next slide, 12 of 12. I was logged into my root container. I want to change over to my new application root. I could log in as my admin user, or I can stay as sysdba and do an alter session and change the container. So I'm still in my same session, but I'm now inside of that container. When I say show container ID, it's 4. Show container name, I get my UW$ root. If I look at my table spaces and my temp table spaces, this is critically important. I have a sysox table space, a sys table space, a temp table space, and an undo table space. Now, I didn't tell it to create another system or sysox table space, but it did. I didn't tell it to create a temp or an undo, but it did. This is part of this cloning from the seed. The table space that you see here is to hold the information about any objects that are created in that container. So it's a full key data dictionary brought in by Pointer that combines some objects coming in from the top, like, for example, DBA tables, all tables. Those might come in, but they would not be showing me anything that was anywhere other than in my own container. I can't see anything up above unless, so DBMS stats, for example, I can see that exists. The source code would not exist in my root container, but the ability to now execute it by executing that pointer does in fact exist. So this is what you're seeing. So build 6 pluggable databases. You have 6 systems, 6 sysoxes, 6 undos, 6 temp table spaces. The majority of these new ones are empty because so far you haven't built anything there. Let's go to the next slide and let's talk about installing an application. When I install an application, this is a huge departure from what you're used to in any previous version or Arca database. Let's go 1 of 5 of demo 2. And here's the syntax: alter pluggable database application. So I'm in an application root, and this is the syntax for altering that pluggable database for purposes of an application. You notice we have begin install, end install, and an application version, begin patch, end patch, begin upgrade, end upgrade. And I'm going to show you these particular ones that I've highlighted in blue, what these look like. What's fabulous about this is that an Oracle database up until now has had no version control for an application. So if some developer wanted to go in there and mess around, there was really no way to tell what they had done. Application versioning and change management control to a great extent is now built into the architecture here, and you'll see that as we go through these next group of slides. So let's go to slide 2 of 5, and you'll see I've done an alter pluggable database application, and there's my application name, begin install 1.0. I cannot do certain activities if I don't say begin install and give it a version number. It will force me to do that. Now, some things you can do, but if you do it that way, then it will not be inherited by Pointer. If you do it with the begin install, end install, begin patch, begin upgrade, then it becomes something that can be shared out of that environment as a shared object. So I begin my install, I create a table space, nothing unusual there. I create a user, nothing unusual here. I grant privileges, nothing unusual here. Let's go to the next slide, 3 of 5. I create a view, I create some tables, create another view. Again, nothing unusual going on here. Let's go to slide 4. I now insert some data. I do an alter pluggable application, my application root name, and I end the install. Now, I could have done some things in here that required that begin install, end install, but I intentionally didn't, just because I wanted you to have a sense of what this looks like with just the begin, do a bunch of stuff, and the install. Now, let's take a look at happens when I look at a brand new data dictionary view, DBA applications. And you'll notice that it's showing me that the application name is UW app. The version is 1. That's what I said. Begin installation of version. Status is normal. And app implicit, I have yet to figure out quite what that means. I'm still trying to research that one. Is set to no. And I've got a little note here that says if there are application PDBs under the application root container, exit and synchronize them with their root. If I had done this and PDBs had already existed, I would have to go into those PDBs and I would have to run a synchronization command. And it's a just really simple little one-line command, and it would synchronize with those changes. Now let's go to the application upgrade. So let's just skip ahead to slide 55, which is Demo 3, Shareable Objects. This is where a building container and having it shared into the pluggable databases underneath it. I could create a normal table, as you see at the top, create table servers. It's not going to share it by pointer into the PDBs under the application root. But in the very next one, you'll notice I have sharing equals metadata. There are a variety of different ways that you can set up sharing. Sharing metadata means that the DDL will be shared into the pluggable containers that go into the root. So you will, in that pluggable container, get an empty table with exacture. Same column, same name, same everything. If you plug 10 PDBs in, all 10 of them will instantly have that table. It will be empty, and they can work with it. You can also say shared data. And if you share the data, what that means is that if you were to put, say, a list of countries and country codes into that application root, it wouldn't just be the DDL that was shared where they'd get the empty table, but they would be getting that same data. The data itself would be shared and everybody could look at it. It would be common data to all of those pluggable databases. Now, in this particular case, on slide 1 of 3, I did not do an alter pluggable database. So the create table works. You can see it says table created. But when I try to do sharing equals metadata, it says missing or invalid option. Well, there's nothing missing or invalid. This is just a really, really poorly written error message on Oracle's part. Because the default sharing for my database, just by the fact that you install one, is set up for metadata sharing. I said share metadata. There's nothing wrong with my syntax and it's not an invalid option. But I didn't say, wait a second, I have an application root. I've done some stuff in there. Now I need to make some changes, and one of those changes is I want to share into those pluggable databases. So let's go to slide 2 of 3. I now try something that will not work. I say begin installation of version 1.0, and it says that 1.0 already exists. Pay attention. And this is where some of this change management and version control power comes from. It knows I've already got version 1 installed and I ended the install. I want to make a change. I'm going to have to change the number. I could go to 1.1, I could go to 1.5, but I have to increment the number. So I say, okay, alter my pluggable database UW app, begin an upgrade of my version 1.0 to 2.0, and then I put a comment in there just so I'd know why I did that particular thing. And now that exact same syntax with sharing equals metadata works perfectly. So it will let me build a normal unshared table without going into this mechanism for begin install, end install, begin upgrade, end upgrade, begin patch, end patch. But as soon as I get into sharing metadata or sharing data or any of the other sharing, it forces me to version control what I'm doing. So remarkably powerful, but as you've just noticed, the error message that comes from not doing that is highly misleading because it would lead you to believe, and certainly led me to believe it for the first hour while I was rattling around trying to figure out what I'd done wrong, certainly would lead you to believe that you had your syntax wrong. So be aware of the fact that it's just a misleading error message. Let's go to 3.3, and I now end the upgrade. I do a describe on DBA applications so you can see what's there. In terms of the columns, I do a select from DBA applications and had version 1.0, and I have now upgraded it to version 2.0. The app name for version 1.0 appears to be something you can't revert to. It looks like you can't revert back to version 1.0. It's not like edition-based redefinition where they continue to exist until you explicitly drop them. It seems to be just more of a note-taking thing. But then, who knows what will show up in Oracle 18 in October. So that may change. But as of 12.2, it shows you your history, but it does not let you go back to version 1. Okay, let's go to the next slide, application seed creation, slide 58, and scoot on to 59. I want to make sure we end on. And I'm doing a create pluggable database as seed. That works just fine. I do a select from $sign containers. Now, you'll remember before when I did select from $sign containers, I was in root. I was in CDB $sign root container 1, and I could see the metadata about every container. Now I'm logged into the application root, so I can look down, but I cannot look up. My view for security purposes is restricted. I can't see the root container above me, but I can see those things that are plugged in below me. So I've created a seed under my application root. When I now look in $sign containers, I can see that I have my root, which is container 4 that I'm in, and I've created a new container number 6, which is my seed for this particular. And you'll notice that the first one where it has those 3 apps is yes, no, no. And the first yes is application root. The second one is no, yes, yes, which stands for application PDB and application seed. So the data dictionary is giving you this view of this information. I tried to open them. I tried to open it read-only. I get errors. You'll notice that that seed is mounted, so I'm trying to figure out how to open it. I'm just showing you my mistakes so you don't make them. And let's go to vert 2. And what I discovered, you created a seed. It is what it is. The process of figuring this out, having looked at those 2 error messages, was I remembered, and which is why I'm including this in here for you, always go and look at trace files. And I can always look at the data dictionary and what goes wrong. So the first thing I did was I went down and I went to my trace directory and I traced the alert log. I'm just giving you a very, very small piece of the alert log. But when I had those violations that you just saw a minute ago, when I couldn't open it read-only or open it read-write, I got a message that said, PDB plugin violation, view for more details. And when I did that, it said, go look at a view called PDB plugin violations, view for more details. I went to PDB plugin violations, and it said, April 19th of 2017, here's your root, here's your seed. It's not an application PDB. Its status is pending. Run this lovely script. It gave me the name of a script. Let's go to the next slide, 61. There's the script. Color code the script for one important reason. The script is non-functional. I opened an SR. I'm sure by now Oracle's fixed it. But if you look at this, I'm just sharing this with you for the humorous aspects alone. You'll see that the SQL that Oracle provides you to fix that problem will, in fact, never, ever run. So be that as it may, with the initial release of 12.2 did have a little problem there. Depending on what you were trying to do, if you did something wrong, it could misdirect you to a script. But that script was written by Oracle and is a non-functional script. That has, in fact, as far as I know. Let's go to slide 62. What I then found was I figured out what, and I was able to make it work. So that's just the nature of how some of those things go. But the database worked just fine, and the seed worked just fine. It was me making mistakes, and the error messages were not appropriate. Let's go to slide 65 on SQLnet. I said this very briefly before. World database containers or PDBs into root containers or application roots, you must manually create an entry in tnsnames.org to access it. So be aware of the fact that even though you can clone a seed or you can clone a PDB or clone a root container, it's going to give you a database, and it's a fully usable database, and 60 seconds later you're ready to rock and roll, except that nobody can connect. So always remember to go in and change TNS names so that it points to it. So I've got a couple of examples here showing how I did that for my PDB prod and my PDB test and another service named PDB dev. So that'll give you a sense of that. Let's go on to slide 66, lockdown profiles. I'll just talk about this very briefly. Security in the container database is phenomenal to the security that you're used to. Right now, if you were a DBA, you wanted to grant somebody the ability to do an alter system, PL SQL, and use CL SQL code type, or do an alter system and set debug or PL SQL warnings. You can't do it. You give somebody alter system, and they can alter system on every single init parameter in the data dictionary. Lockdown profiles allow you to grant a privilege that is very broad and then narrow it down to be extremely specific. So the lockdown profile I've got here, I created a lockdown profile called Devels, PDBs, Developers, Pluggable Databases. I said disable the alter system statement with the set clause. So you can still do alter system stuff without set potentially, but disable it with the set clause, except if they're doing alter system set PL SQL code type, alter SQL set PL SQL debug, or alter SQL set PL SQL warning, and then later on down near the bottom you can see that I do at the very last line. The very last line. I do a grant and I do an alter system to a PDB user. I've granted them alter system. Normally that would scare the living daylights out of me, but because I've created a lockdown profile, I know they can only do 3 separate alter system commands. So lockdown profiles should be at the top of your list of things that you learn to use with the pluggable databases. Let's go to 68. I'm just going to wrap this stuff up pretty quickly here in the interest of built-in packages that you want to be paying attention to. These are all fully documented in terms of the subprograms I'm showing you. There's a DBMS PDBs that allows you to manipulate information about pluggable databases. I've got a demo here on slide 69 showing how you might check plug-in compatibility. If you were to want to unplug something from one and plug it into another container, you can check plug-in compatibility, one of its capabilities. Let's go to slide 70. There's a PDB execute SQL, which is a standalone stored procedure and allows you to execute Oracle things as Oracle script. Now, Oracle script is something you probably will never want to do unless you're on the phone or you have an SR open and you're working with Oracle support, in which case there are sometimes you need to execute things as Oracle script, which essentially means that you're now running in a executive capacity doing some kind of an ad hoc one-off patching of the data dictionary. So just be aware of this PDB execute SQL. There's a PDB alter sharing, which allows you to share. Notice how I showed you earlier about doing sharing equals metadata. I talked about sharing equals data. The alter sharing allows you to change that sharing. So you could have something as sharing as not sharing, or you want to change it to something else to change the nature of that sharing and how it. There is a built-in package for synchronizing and refreshing material across pluggable databases in 12.2, and again, documented in the Oracle types and packages, documentation. Just be aware it's there, and you're going to want to learn about it. Let's go to slide 73. I've got a small example here where I'm saying, the refresh stats, retain the stats for 90 minutes or 90 days. So again, some new objects here, some new built-in packages that are important for learning how to manage pluggable databases to make sure they stay synchronized the way you want them to. So slide 75, the conclusion. Docs. Download the installation files from otn.oracle.com, install it, and learn it. And I can't emphasize the importance of learning it, because Oracle has made it very clear to those of us that were beta testing and are involved in this that they would love to have the old architecture go away. And if you like your job and you like your payroll, sticking with the old is possibly not the best career move in the world. I just had somebody at a conference that I was at about 3 months ago just about faint, because I said in 12.2 Oracle has removed all of advanced replication. So all that materialized view replication stuff that Oracle's had around for 20 years is now gone. It's not just deprecated, it is literally gone. The packages are gone, the tables are gone, the views are gone, and this person went, "You've got to be kidding. That's how everything at our company runs." And I said, Oracle told you 15 years ago, they were deprecating that thing and wanted you to move to streams. And he said, "Yeah, but it was still working and our management didn't want to do it." And I said, "Well, guess what? By the time you get to 12.2, you're going to have to rebuild your entire infrastructure for replication." I suggest Golden Gate. So it really is important to get there, and I've got a couple of slides here at the end, which I'm not going to talk about, which basically step you through where to go to get the 12.2 documentation, docs.oracle.com, and where to get the Oracle 12 database and download it. What you see if you go to otn.oracle.com, you should see exactly the screens that I'm showing here. So with everyone for coming, I hope this was a good use of it. I'd like to thank Frank in particular for inviting me to do this, and my only regret is that I'm doing this by webinar instead of being on an airplane and being in a country that actually has some elements of sanity left in it, because this one certainly doesn't. Thank you very much.
All right. Thank you so much, Daniel. It was an amazing presentation. I'm sure everyone appreciated it. I haven't been asking for any questions, and no one have responded with questions. I'm just giving a few seconds due to the delay to see if anybody else has any question. If not, we are ready to wrap up.
Wonderful. Well, on my slides, you are welcome. You are welcome to take my slides, turn it into a PDF, and distribute it to everybody who wants a copy. It has my contact information. If people would like to shoot me emails, I am more than happy to answer emails. Or if they'd like to shoot questions to you, you can send them to me. Whatever works best for you.
Fantastic.
But certainly, you are welcome to distribute the slide. Turn it into a PDF. Distribute the slide deck to anybody who wants it.
Fantastic. Thank you so much. And your contact information is now on the screen also, and the people can take that information from there. All right. Looks like is no questions at all. Saying that, thank you so much, Daniel, and looking forward for the next one.
Thank you very much. I'll try to just to not speak with such a strong accent next time. Maybe that's the reason for questions.
Thank you.
Bye-bye.